welcome you in the new physics class again, and today's topic will be units and measurement for class 11, and this is the continuation of the previous video, and I named this as part 2. Okay, and in today's class we will try to discuss mainly about the errors. Okay, and the different types of errors and the combinations or propagation of errors. So we have to discuss these errors in a very elaborate way. Now, what is meant by this error? And the lack in accuracy in the measurement due to the limit of accuracy of the instrument or due to any other cause is called an error. You know that I have told you many times that for any measurement, error cannot be separated, or error cannot be going away from that measurement. So your measurement always has an error. Whether that error is a small or large, that is a different thing, but for every measurement there will be always an error associated with it. If the error is small, then your measurement is more accurate. If your error is very large, then your measurement is not accurate. Okay, so what happens if there is an error? Then what are the different types of errors that are coming up? Okay, that one we need to learn it. The first one is what? Your absolute error. We call it this, the first one, absolute. Why? Because this absolute has no sign. Okay, that means absolute means it will be always considering about the magnitude only. Whether that magnitude is less than the actual true value or more than a true value, doesn't matter. It consists we have to consider only about the magnitude. Okay, when I say true value, what is a true value? You must be very new to this word true value. What is meant by true value? True value is nothing but for any measurement the actual value of the measured quantity. We call it that as true value. The accurate, the actual true measurement, okay, or rather the correct value of the measurement, we call it that as what? True value. Suppose you are going to measure the mass of a given body, okay, and if that given body is exactly 1 kilogram, okay, then the true value of that measurement of mass is what? 1 kilogram. Okay, if you ask to some students or to some of your friends to measure to what the value or the mass of that body, and if one measures suppose 980 gram, then 20 gram is the error. Okay, so we need to find it out what is error. Okay, and the first one is what? Absolute error. The difference between the true value and the measured value of a quantity is called absolute error. So in that example that I have cited you, that means what? Your absolute error is nothing but a difference. When I say difference, that means it should be what? Bigger or larger value minus the smaller one. So the difference of this true value and the measured value, the difference of these two quantity, what are the two quantity? True value and the measured value, the difference, I mean, okay, we call it that quantity as the absolute error. In that example I told you about the measurement of a mass of a body, and a true value is what? A true value is what? True value, I told you that it is 1 kilogram, and this 1 kilogram means if I express it in gram, it will be 1000 gram. Okay, and the measured value found by a person or by a student, that measured value, let me write MV only, okay, in short, then it will be what I said. I have given you the example of 980 gram. Okay, So what is the measured value? The measured value is 980 gram. True value is what? 1000 gram. Okay, so the difference between this true value and the measured value, we call it that as absolute error in that measurement. So we are going to take the absolute error. Absolute error means what? Difference between this true value and the measured value. So difference means what? Larger value minus smaller value. That means larger value means true value. Difference of true value and measured value is what? 1000 minus what? 980. That means 20. So your absolute error in that first measurement will be what? In the first measurement will be what? 1000 minus 980 means what? It will be 20 gram. Okay. Suppose in the second measurement, let's take it for the second measurement, which is denoted by A2. For the second measurement, if you ask another person, or if you measure it again, then in the second measurement, the measured value, say suppose let's take it that the measured value comes out to be say 1005 gram. Okay, 1005 gram, like this. Then what happened in that absolute error for the second measurement will be difference of this true value, okay, and the measured value in the second measurement. So how much it will be? Which one is bigger? Measured value in the second measurement is more than the true value, right? So 1005 minus 1000, it will be how much? It will be 5 gram. So you have to take it this absolute error as what? Absolute error in the measurement is what? In the first measurement it is 1000 minus 980, which is equal to 20, and in the second measurement the absolute error is what? 1005 minus 1000, that means it is 5 gram, like that. Okay, so like that, if you try to find out the absolute error for different measurement, then you will get it. Okay, now let's try to find out mathematically. Okay, now you see that there in the, if this is a description, okay, if a1, a2, a3, so on are the measured values of any quantity in A. So this a1, and in the previous that one I have told you that these are the absolute errors, but I just make it just to make you understand it. Okay, but these a1, a2, a3 are not the absolute error, rather these are the measured what? Values of different measurements. Okay, so if a1, a2, a3, so on up to an are the measured values of any quantity A in an experiment performed n times. How many times you measure it? You measure it n times, and for that n measurements you are having those measurements a1, a2, a3, so on up to an. Okay, then the arithmetic mean of this value is called true value A of the quantity. Okay, we don't know what is the true value. Okay, that means what is the exact value of that measurement, we don't know. But by taking all those measurements, okay, the average of all those measurements, we take it that mean or average of all those measurements as the true value, and it is denoted by am. So the difference between am and a1, that will be the absolute error in the first measurement. Can you get my point? First, an object is given to measure its mass in that previous example that I have cited. Let's take it that you are given an object like this, and we don't know what is the true value of this. That means the exact mass of this given body we don't know. So we need to take it a true value, okay, by what? By the mean of all those what? Measurements. Mean means what? Average value of all those different measurements coming up in that what? Different experiments. So how many times you measure the mass of this given body? You are measuring n times, and in the first measurement you are getting the mass as a1. It may be mass, or it may be length, it may be area of any given body. Okay, but let's take it in that I have given you as mass. So let's take it, this is a given body of whose actual true value mass is what, am. And how to find it out this am? We need to have the what mean of different what measurements of mass of this given body. Suppose in the measurement of mass, if you take it that this a1 is the first measured value, a2, a3, so on, okay, up to what, an. You measure it, this different what body of whose mass are found to be a1, a2, a3, so on up to an. That means you are experimenting it or you are measuring it n times, okay, n times. And so for n measured quantities will be coming up, got it? N measured values will be coming up. So this is the first measured value, second measured value, third, fourth, so on, and it will be the nth measured value, okay. And if you want to find out this am, the true value, okay, the true value of that given object, then you need to take the average of all these measured quantity. How? We know that a mean or average means what, you need to sum up all the measured values, okay, so on, a1, a2, a3, so on up to an. And how many observations, how many measured, how many times you measure it, n times, right? 1, 2, 3, 4, so on like that up to n. So the number of observation is what, n, got it? So these will be considered or taken as the true value of the measurement of the mass, and which is denoted by a, and so we have to denote it by am. Am means a mean, okay, m for mean. So what happened, this a mean or am will be considered as a true value. And to find it the absolute error in the first measurement, what happened, you need to take a difference of this am and a1. That will be the absolute error in the first measurement. In the second measurement, the absolute error in the second measurement, I mean it will be am minus a2. But while you are taking that, we don't know am will be what, greater, or a1 will be greater. So you need to take it that the modulus of what, am minus a1, like this, modulus of am minus a1, whichever is greater. Suppose if a1 is larger than am, then it will be coming up to be minus something, okay, minus a. Let's take it the difference of these am and a1. Suppose if it is coming as minus a1, as it is modulus here, it will be always what, positive, got it? It will be always positive. That is why you need to take it only the magnitude, as I said, absolute means, got it? So let's see in the next slide, it will be there, okay. If you want to note down, okay, then you can pause it and you can what, write your notes also even, okay. Now see, the absolute error in the measured value is given by what, delta a1. Delta represents what, your absolute error. So your absolute error in the first measurement, your absolute error in the first measurement is what, here they are not giving as modulus, but in fact it should be given as what, modulus. Here there it should be having like this, okay, for each and every of this. That means you have to take only the magnitude, okay. The absolute error in the measured value is given by what, for the first measurement. That means this is the absolute error in a1 will be equal to a mean minus a1. What is this a mean? We consider this as a true value. So true value and the measured value, the difference of these will give you the absolute error in the first measurement. Likewise, absolute error in the measurement of the second quantity, it will second observation or second experiment, delta a2 will be equal to am minus a2. This will be not a1, rather it should be a2, okay. Likewise, you keep on going that absolute error in the measurement that means A3 will be equal to what? Delta A3 will be equal to modulus of AM minus A3, like that. Got it? So if you go on so on like that, 3, 4, 5, and if it is for the absolute error in the measurement of that nth observation, then it will be equal to what? Delta A, and this will be equal to modulus of what? Modulus of this one, it will be equal to A, and this will be A and not M. Okay, A n minus what? So on. If you go on, then it will be equal to what? A n. This will be equal to the mean. I mean, why I'm writing this as M? It is mean. Okay, so AM minus AM means the true value. Okay, the true value. This will be also the true value. The true value. Okay, and that of the last what? Observation or measurement. So your A delta AN is the absolute error in the measurement of AN, and that will be equal to modulus of A min minus AN. Got it? So likewise you need to find it out for different measurements like that. Okay, then we know that what is absolute error. Absolute error is nothing but this is the difference of true value and the measured value. We call it that difference as the absolute error. Now let's go to the next one, which is also known as mean absolute error. Now you are having absolute error in the first measurement, absolute error in the second measurement, so on up to what? Nth. Okay, that means absolute error in the nth measurement. So what happened? This will be equal to, this is a different one. Okay, it is not here. This is for all delta. Okay, so let me erase it all. It should be delta. This one is a different one. This one means this one is a different one, because this is a difference in what? Delta. Okay, now let me go to that one of the mean absolute error, and let's remove it, all these things, erase it. Okay, now mean absolute error. Mean absolute error is nothing but this is the arithmetic mean of the magnitude of those absolute errors in the measurement. Okay, suppose if you are given to measure the mass of a given object, and then you find it out all those measured quantities as these are all A2. Okay, like that, so on. So you will find what? Delta A1, delta A2, so on up to what? Delta AN. Got it? So this delta A is what? This is the absolute error of what? The true value and the actual measured value, difference of the true value and the measured value in the first observation. We call it that as absolute error in the first measurement. Absolute error in the second measurement will be equal to what? The difference of the true value, that means we have taken as AM minus A2. Okay, that means in the second measured value it should be A2. Okay, the second measured value A2. Likewise, if you want to find out for the third measurement AM, the absolute error in the measurement, in the third measurement I should say, it will be difference of the true value, which is considered as the mean of observation, minus what? The third measured value. Okay, likewise if you go on, so on like this, then the the nth absolute error in the nth measurement will be equal to what? The mean or the true value minus that nth measured value. Got it? Likewise you will get it. So what happened in the mean absolute error? It is very simple that this mean absolute error is nothing but this is the mean of all these absolute errors in the measurement. Got it? So your delta, that is mean absolute error, is denoted by what? Delta A bar. Bar means what? Mean. Okay, or Bar means what? It is the arithmetic mean or the average value. Got it? So mean of all those what your absolute errors, we call it that as mean absolute error. Simply mean of all the absolute errors in a measurement, okay, we call it that as mean absolute error. And that mean absolute error, it is denoted by here. See, you will see that absolute errors, it is denoted again by modulus here. Okay, modulus means you need to take it only the magnitude of all those absolute errors, right? So your delta a bar, which represents mean absolute error, will be equal to what? Delta A1, that means this is the absolute error in the first measurement, absolute error in the second measurement, so on up to absolute error in the nth measurement. So if you counted this, okay, then it will be 1 2 3 so on up to n. So you need to divide it by the number of observations. How many observations? 1 2 3 4 5 so on up to n observation. So you need to divide it by n. Got it? Sum of all the observations divided by number of observations, we call it as mean, right? So that means this is the mean of those absolute errors. We call it simply as mean absolute errors, right? Now next is the third one is what? Relative error. This relative error is nothing but this is the what? Ratio of mean absolute error to the true value. Mean absolute error is denoted by delta A bar, right? So your relative error is defined as a ratio of mean absolute error to the true value of the measured quantity, okay? And it is expressed as delta A bar divided by AM. AM is taken as true value. That means mean of all those observations, okay? All of those observations, or you can say measured values. Mean of all the measured value, we call it that as A mean or true value, right? Now let's go here, what is known as the last one, the percentage error. The relative error expressed in percentage is called percentage error. Percentage error means relative error into 100%. We call it that as relative error. A relative error percentage or percentage error, we simply call it, okay? Yes, what is this percentage error? Percentage error is nothing. If you express that relative error in terms of percent, then we call it that error, relative error, as percentage error or percentage relative error. Got it? So the formula is what? The formula is nothing but your percentage error will be equal to what? Relative error times 100%. Got it? Yes. Now let's go to the combination of error, or we also call it that as propagation of errors. Suppose if you are going to find out a physical quantity which is expressed as a sum or a difference of another two physical quantity, then how much error will be coming up in that measurement, okay, of that physical quantity. Suppose you are given a physical quantity which is represented by x, and this x is expressed as a sum of two physical quantity. Suppose you are given, as I said, you are given a physical quantity x, okay, and this physical quantity is expressed as a sum of another two physical quantity a and b. Then in the measurement of a, you will come up with some error. In the measurement of b, error will be also there. So what will be the error in the measured value of this x? We need to find it out, okay? Either it may be in the sum or a difference, or it may be in the product, or it may be in the what? Quotient also. Got it? So we call it this as combination of errors or propagation of errors, okay? Now here, see, if the measured value of the two quantities a and b are what? A plus minus delta a and b plus minus delta v. Suppose in a measurement, if a is taken as the length of a pencil, okay, length of a pencil. Let me draw the pencil somehow like this, just a rough one, okay. And if you are trying to measure by using a scale, okay, this will be the 0 mark on that scale, okay. And let's take it that these are the different points on it graduated on the scale. And if that length comes out to be, suppose, I mean a true value, if it is coming out to be 5 centimeter, okay, in terms of centimeter. And then if this 5 is a true value, and in the measurement by another person, if that measure value if comes out to be of 5.05 centimeter, okay, then the error is how much? 0.05 centimeter, okay. And so we generally say that the measured value lies between what 5 centimeter minus what 5, the error is how much? 0.5. so I'm sorry, it should be 0.5. So let's take it that as difference is what the error is what 0.05 centimeter, and the measured value, okay, if in this measurement of this length of the pencil, which is of whose true value is 5 centimeter, and if it is measured by a person, and if the error comes out to be what 0.05 centimeter, then the measured value will surely lie between what 5 minus 0.5 to 5 plus 0.05 centimeter, okay. So we write it this as what from minus, that means the true value minus the error, to true value plus the error, okay. So your measured value of the pencil of whose error is found to be what this 0.05 centimeter will surely lie between what 5 minus 0.5 means what it will be 4.95 to 5.05 centimeter, okay. The measured value will surely lie. What is this 4.95? 4.95 is nothing but this is the true value minus that error, okay. And 5.05 is what 5 plus the true value plus the error, okay. So that is what it means here, got it. So if the measured value of the two quantities A and B, okay, are what A plus minus delta A, means what the true value lies between what 4.95 to 5.05. that is the meaning. Or rather you can also say like this, if the measured value of two quantities A and B are A plus minus delta A and B plus minus delta B, means what this delta A is nothing but this is the error in the measurement of A, got it. And the measurement in the measurement of B, delta B is the error. What type of error? Absolute error, got it. So your measured value of A will surely lie what in between A minus delta A to A plus delta A. So we generally write this collectively as what A plus minus delta A, got it. So that is what it means here, the measured value as A plus minus delta A. Similarly like that for the measurement of B, what happened? The measured value will be taken as B plus minus delta B, got it. Then the maximum, if the measured value of two quantities A and B are A plus minus delta A and B plus minus delta B, then the maximum absolute error in their addition or subtraction will be what? This is what measured error in what? X, okay, or rather you can call it in a very comprehensive way, you can say as the absolute error in the measurement of x will be equal to what? The sum of the absolute errors in the individual quantities. Okay, if x a physical quantity means a measurable quantity. Suppose you are going to measure the length of a given body. Okay, the length of a given body, suppose for example like this length, if you divide it into two like this, one part A, another part B, like this, you are going to measure the length of this. Okay, but if this is not continuous, okay, you need to measure the length of A separately, the length of the B separately. Okay, then what happened, you will need to find out the absolute error in the first measurement, and you need to find out the absolute error in the second measurement, so that what happened, the sum of these two quantities A and B will give you that x. Okay, for example, in the case of perimeter of a rectangle, okay, that will be equal to what? 2 times of what? Length plus breadth, right? So you need to measure the length also, the length of the rectangle as well as breadth of the rectangle. The sum of these two times 2 will give you what is known as perimeter, but this 2 is a constant quantity, and so there will not be any error. So while measuring the length, you will come up with error, and that error we call it as absolute error delta A. In the measurement of that breadth, okay, there will be also what? Your error again, and that error we call it that as delta B. So your measured value of that breadth will be denoted by this, measured value of that length will be denoted by this, A plus delta A. Okay, so the length we may call it as A. Okay, likewise, what happened, while you are trying to measure the parameter, then what happened, your error will be, your error in the measurement of such perimeter will be equal to the sum of the what? Error in those two physical quantity. Got it? Same is the case in the case of difference also. Got it? Whether it may be difference or sum, the error will be always added up. Got it? And in the case of multiplication and division, what happened, the relative error will be added up. Okay, here it is absolute error in the case of sum or difference. Okay, the relative error in the measured quantity will be the sum of the absolute error in the individual quantity. Okay, but in the case of multiplication and division, it will not be the absolute error, rather it will be the relative error, whether it is multiplication or whether it is division. What happened, the what? Error in the measurement of a physical quantity which is expressed either as a product or a quotient, it will be always the sum of the relative errors of those individual quantities. Suppose in that product, suppose these two A and B are the two physical quantities, the product of these two quantities gives you a physical quantity. Then there will be relative error in the measurement of A, and it will be denoted by delta A by A. In the measurement of B, there will be also relative error, and it is denoted by delta B by B, right? So what happened? This relative error, okay, relative error in the measurement of two physical quantity A and B, what happened? The sum in the measurement of this x, okay, x is expressed as a product of A and B, right? So x is expressed as a product of A and B. In the measurement of A, relative error of A is expressed as delta A by A. Relative error of B is expressed as delta B by B. So in this measurement of x, what happened? The error will be what? The sum of these two relative error. So your delta x, okay, measurement in this measurement of x, the relative error in x is denoted by delta x by A. Okay, this relative error will be equal to the sum of the relative error of those two multipliers. Okay, A and B. Same is the case in the case of division also. Okay, whether it is division or multiplication, the error will be always added. What type of error in this multiplication and division? It will be the relative error. So relative error in the measurement of x, which is expressed as a into b or a by b, it will be always equal to the sum of the relative errors of those individual multipliers. Okay, got it? Let's try to prove it this. Okay, it is generally asked in the examination, so I will try to do it in a very elaborate way. Okay, now let's try to have it the proof of this. Okay, suppose this is for the sum of the physical quantity. So let's take it that a physical quantity, okay, which is given as x. What is this x? X is a physical quantity. Just like that, I have given you to measure the length or the perimeter of a rectangle. Okay, if you are asked to find out the perimeter of a rectangle of whose length is denoted by L and breadth denoted by B. So for the sake of simplicity, to measure length, let's denote it by A. So that means perimeter Z is expressed as 2 times of what? A plus B, like this. Okay, but for the time being, let's remove this 2. Okay, let's not have this 2. Why? Because let's express it only as a sum of the measured quantity of 2 physical quantity, length and breadth, for example. Okay, so a physical quantity is expressed as the sum of another 2 physical quantity. Got it? So what is this Z? This is a physical quantity, and this is A is also what? A physical quantity. B is also what? A physical quantity. Okay, that means all are measurable quantity, but this Z is expressed as a sum of 2 physical quantity A and B. Okay, let delta Z, okay, be the absolute error in the measurement of Z, delta A and delta B be the absolute error in the measured quantity of A and B respectively. That means your delta Z, delta A and delta B are nothing but these are the absolute errors in the measurement of Z, in the measurement of A and in the measurement of what? B. Got it? Then their measured value will be what? For Z it will be delta Z, okay, plus minus, do you remember? Delta Z. Your measured value will lie from, your measured value will lie from where to where? This is Z. The measured value will lie from Z minus delta Z to Z plus delta Z. Got it? And similarly for that of this A, the measured value will lie from where to where? A minus delta Z to A plus delta Z. So we express it like that. Got it? A plus minus delta Z. And for similarly for that of the B, it will lie from B minus delta B to B plus delta B. Got it? What is this? This is the measured value of B. This is what? Measured value of A, and lastly this is the measured value of Z. So what happened as Z is expressed as a sum of that A and B, what happened? Its measured value of Z will be also lying what? In between these two, like this we can write it. Okay, so your measured value will be what? Z plus minus delta Z will be equal to A plus minus delta A plus what? B plus minus delta B. Got it? So what happened? We can express this as, you try to bring this B, okay, you try to bring this B here associated and your relative errors separately, so that we can write as A plus B plus minus delta A plus minus delta B, like this we can write it, right? So this is equal to A plus B. You can take it this common and it will be delta A plus of delta B. Got it? But this a plus b is what? A plus b is nothing but this is z. So your z plus minus delta z, okay, this is z, so this is also z. You can cancel it, these two, so that what happen, your plus minus delta z will be equal to what? Plus minus of delta a plus delta b, right? So what happened, the maximum value of error is what? Delta a plus delta b. So your delta z can be expressed as what? Delta a plus delta b, right? So what happened, when two quantities are added, what happened, the absolute error in the final measurement is nothing but this is the sum of the absolute error in the individual quantities, okay? So this is about the sum of two physical quantity, okay? A physical quantity which can be expressed as a sum of two physical quantity. Now I'm just repeating again. Suppose we have a physical quantity z, okay, which is expressed as a sum of another two physical quantities a and b. Let what happen, delta z, delta a and delta b be the absolute error in the measurement of these three different physical quantities z, a and b respectively. What are these? Delta z, delta a, delta b. Delta z, delta a, delta b are the absolute error in the measurement of z, a and b respectively. So the measured value of z will be expressed as z plus minus delta z. It will be equal to what? Measured value of a is what? A plus minus delta a. Measured value of b will be what? B plus minus delta b. From this equation you just write the measured values, okay, for z, for a and for b, like that. Then you try to associate this a and b and the absolute errors, you keep it on one side, okay. That means on the right side like this. So taking this plus minus common, got it, you can write like this. A plus b is what? Z. So this z and this z will be cancelled, and so your delta z will be equal to what? A plus delta a plus delta b. So as I said, when two quantities are added, okay, the absolute error in the final measurement is nothing but this is the sum of the absolute error in the individual quantities. Same is the case when we consider about the difference, okay. When we consider about the difference, then what happened, this will be what? Minus, right? So all these will be minus. Let me change it here, okay. Yes. Now if a physical quantity z is expressed as a difference of two physical quantities, that means z will be expressed as a minus b. We have said that delta z, delta a and delta b are the absolute error in the measurement of z, in the measurement of a and in the measurement of b, like that, right? So your measured value of z will be z plus minus delta z. Measured value of a will be a plus minus delta a. Measured value of b will be b plus minus delta b, right? So what happened, if you try to express their measured value, then z plus minus delta z will be equal to a plus minus delta a minus of b plus minus delta b, right? So if you bring this, if you open it this, then it will be minus b. So you bring this minus b near to a and it will be written as a minus b. From there you take it plus minus, okay, common, and if you just open this bracket, then it will be minus plus. First you need to multiply it with this plus, next you need to multiply it with this minus again, okay. Then what happened, minus or plus minus will be minus, minus minus will be plus, okay. Then it will be like this, got it, minus plus of delta b. That minus plus or plus minus is same in this case, okay. So what happens when you open the bracket? It will remain as plus minus of delta b. Minus plus delta b and plus minus delta a are same. So instead of minus plus writing minus plus delta b, you write it as simply plus minus delta b. Got it? So let me remove it, this portion. Erase it. Okay. Now then let's go again. Then what happened? This a minus b. This a minus b is same with that one z here. So this will be minus in that case. Okay. This will be a minus b. So a minus b is z. On the right left hand side also one z is there. So you cancel it these two. Got it? Then what happened? You will get it as plus minus delta z as plus minus of delta a plus delta b, right? This was having. So you just cancel it, this plus minus from both the sides. So you will get as delta z will be equal to what? Delta a plus delta b. So what you have that if a physical quantity is expressed as a difference of another two physical quantity, then we found that the absolute error in that physical quantity as what? The sum of the absolute error in the individual physical quantity. So collectively, for sum and difference, we can say that when two physical quantities are added or subtracted, the absolute error in the final result is the sum of the absolute errors in the individual physical quantities. Got it? Yes. Let's go for the product. Okay. And for the quotient, that means for if z is expressed as a product of two physical quantity, okay, or if z is expressed as the division of two physical quantity. Got it? Let's do it that one. Before going to this, let's try to have that for division and for the quotient. Okay, now as we have taken that, let's take a physical quantity z which is expressed as a product of two physical quantity. Got it? Product means not this one, I'm sorry, not the sum. I was acquainted with writing that sum, okay, as we were doing the sum. So let's do it as the product, okay, a into b. What is this z? We are going to find this physical quantity z, we are going to measure it, and this z is expressed as a product of another two physical quantity a and b. Got it? We need to measure a, we need to measure b. So in the measurement of a and b, similar to that in the previous case of sum or difference, error will be coming up. Got it? And that error, absolute error, let's denote it by delta z, as we have done in the measured quantity of z. For the measured value of a, let delta a be the absolute error. Similarly for b, it will be delta b. Okay, so we can express this product as what? The measured value will surely lie from z plus minus delta z. Okay, this will be expressed as a plus minus of delta a times b plus minus of delta b, like this. So if you do that simplification, then it will be equal to what? AB. If you try to multiply it with this one, okay, and with this one, it will be equal to plus minus b times of delta a, right? Then you try to multiply it with delta b again, so that it will be equal to plus minus a into delta b plus minus of delta a delta b, like this. You know that error is always a very small quantity. Okay, so what happened if you try to open the bracket by multiplying b with a, then you will get it ab. B with plus minus delta a, you are getting this one. Similarly, delta plus minus delta b with a, if you multiply it, then you will get it this plus minus a delta b. Then if you multiply it with this, it will be plus minus delta a delta b. Okay, but this delta a and delta b being the absolute errors of two physical quantity, delta A is a very small quantity, delta B is also very small quantity. So the product of these two small quantity will be very small. Got it? So but keep it for the time being. Okay, let's do it for the further simplification. Now on the left hand side, okay, it will be z plus minus delta z. Okay, so if you divide this what above expression, this expression I mean, then by z you will get it like this. Divide the above expression. I'm not going to write the next step, okay, just I'm writing like this. You divided both sides by z. So on the left hand side you divide it by z, on the right hand side you divide it by a into b. A into b is z. Okay, so if you divide it by ab here, it will be divided by ab. If you divide it by ab here, it will be like this. Okay, a into b. So if you cancel with bb, then you will get delta a by a only. Okay, if you divide it here by a into b, then you will get it what, after cancelling bb you will have only b, so it will be cancelled like this. Okay, so and here by ab, let's write like this. So what happens when you divide it with this z by z, you will get what, 1 plus minus delta z by z. On this left hand side, ab cancel, so it will be 1 plus minus delta a by a plus minus delta b by b. And you see here, as I told you, that delta a is a very small quantity, delta b is also a very small quantity. Okay, so your delta a by a will be a very much smaller quantity. Delta b by b again will be again a much smaller quantity. So when you multiply two much smaller quantity, it will be again much smaller. Okay, so this can be neglected, as this is very small when you compare with the other remaining. Okay, so we can neglect this and we will simply write like this. So again 1 and 1 can be cancelled. So whatever you are having is what, z plus minus delta z by z will be equal to plus minus delta a by a plus delta b by b. Got it? So if you take it in the next step, then it will be equal to what, z plus minus delta z by z, this one I mean, will be equal to plus minus of delta a by a plus delta b by b. So what happens when a physical quantity is expressed as a product of two other physical quantity a and b, then the relative error in the measurement of that z is equal to the sum of the relative errors in that individual measured quantities. Okay, so what happens when two quantities are multiplied, the relative error in the result is always the sum of the relative errors in the multipliers. Got it? So this is about the product. Now let's see for the what, the division of a physical quantity. Okay, difference let's take it that z is a physical quantity and it is expressed as the division of another two physical quantity a and b. So z is a physical quantity which is expressed as a division of another two physical quantity a and b. So z is expressed as what, a by b. Same case we did about that. Absolute error in z is delta z, absolute error in a is denoted by delta a, absolute error in b, let's denote it by delta b. Okay, then what happened, we can express in the same fashion that we have done in the case of product. So your measured value will lie between z plus minus delta z. Okay, this can be expressed as what, a plus minus delta a, b plus minus delta b. Got it? So what happened, we can write these as a plus minus delta A. If you try to bring this denominator in the numerator, then it will be what? B plus minus delta B to the power minus 1, right? Before going further, I would like to tell you about a theorem. You might have been knowing about the binomial theorem, right? So if you want to know that binomial theorem, then we are going to apply here the binomial theorem. Let me write the binomial theorem right first. What is this? This is nothing but this is the binomial theorem. Got it? Let's try to write this binomial theorem. What is that? 1 plus x to the power n. This will be equal to what? 1 plus nx plus of n into n minus 1 divided by 2 factorial, into x to the power what? Square. There is power 1, here is power 2, and the power will keep on increasing. N into n minus 1, n minus 2 divided by 3 factorial, and the product here, it will be what? X to the power 3. So on it will go on, right? Where what? This n is a positive integer, or it may be also positive or negative fraction. What I said, n, this, power n, this may be what? Integer. It may be integers, or it may be also fraction also, whether it is positive or negative, and it can be also what? Fraction. Got it? I cannot write nicely because I'm writing with my mouse, so let me write in this way so as to make you understand. So this n is what? N can be integers. Integer means plus minus will be there, and it can be also plus minus fraction. Got it? And what about this x? When you compare this x with 1, x must be less than 1. So we generally write it that this x, whether it may be plus or minus, doesn't matter, it must be less than what? 1. Got it? This value must be less than 1. Got it? When this x is less than 1 in comparing with this 1, so 1 plus x, that means this x is a very small quantity. So 1 plus x to the power n will be equal to 1 plus nx plus n into n minus 1 divided by 2 factorial into x square, plus in the next term it will be n into n minus 1 into n minus 2 into x cubed divided by 3 factorial, and it will go on so on like that. If these two, the term here, this is plus. If you are having, let me write it again. So it will be what? 1 plus x to the power n. If this sign plus here and plus, if they are of same sign, if it is minus 1 here, the power is also minus, then it will be of plus sign like this. If these signs are different, either it may be plus here and minus here, or minus here with plus. If the sign of these two are different, then it will go on alternately with minus sign. Plus minus like that. So that is all about your binomial theorem. You try to pause it and you try to observe it. Then we are going to use this binomial theorem or binomial expansion, you can say. Now let's go it further. Let me erase it, these things, and then we will go to that of what? The next simplification. Now you see this here, this one we can use it with what expression? This can be used as or written as a plus minus what delta a b. You can take it b common there, okay, then it will be b to the power minus 1, and then you can write it as a plus minus delta b, okay, to the power what minus 1. Here when you compare it, that delta b, I told you that delta b must be a very small quantity, so delta b is a very small quantity, okay. Now we know that always error is a very small quantity. Now let's try to divide it, okay, let's try to divide it the both expression by z. Before that, let's write it again, z plus minus of delta z. This can be on the right hand side, we can express it as, after taking common from here, a, okay, a divided by b. This b to the power minus 1 you can bring down again to the denominator, so a divided by b. In this numerator you will have 1 plus delta a by a, right? And what remains here is what? 1 plus minus delta b. I'm sorry, there must be b, another b here, okay, b there, like this, to the power minus 1. Now we can apply that binomial expansion here in this factor, okay, 1 plus minus of delta b by b to the power minus 1. Why? Because this delta b, as it is very small again, okay, why? Because delta b divided by a bigger quantity b, okay, to a small quantity you divide it by a bigger quantity, then the whole thing will become very smaller, right? So this delta b by b is less than 1, okay, less than 1, so we can apply your binomial expansion here. So that what happened in the next step, okay, you can do like this. Let me take it to the blank screen again so that we can write it. So on the right hand or on the left hand side, you will have what? Z plus minus of delta z divided by z, right? So if you divide it by z, then you will get it as what? Now let me write the previous equation, okay, so as to make you understand more. So this will be equal to what? A by b, as I have written like this, 1 plus minus delta a by a, and here it will be 1 plus minus delta b by b to the power minus 1, right? So if you divide the whole equation, okay, and the whole equation by z, or before that we let's apply the binomial expansion. Yes, we haven't applied the binomial expansion, so let's write it, that binomial expansion of this factor, okay. So a by b, 1 plus minus delta a by a, and here when you apply that binomial expansion, then it will be plus minus of what? Delta b by b, okay, and 1 into x to the x means your b by delta b, okay, x to the power 1, plus you need to have that what your n into n minus 1, like that you need to come up, and this square of delta b by b will be coming up in the next subsequent step. Next, in the next term, it will be delta b by b cube, like that it will come up. So as this delta b by b is a very small quantity, and if it is coming as a square, that means it will be a much smaller quantity. So we will neglect it, all those higher power order of delta b by b onto this right side. So we will neglect it, all those comes that is coming up. So by neglecting all those higher power order of delta b by b, we can simply write only up to here. Got it? Why we are not writing all those remaining terms? Because that will contain higher power order of delta b by b. This is the second term. In the third term, okay, you will contain delta b by b square. In the next term again, you will contain delta b by b cube. So all those smaller quantities, if you multiplied it, then it will be a very smaller quantity. So all those can be neglected, and we can write it only up to this. So we will write it here, okay, as a bracket here. Got it? Then what happened? If you divide the whole equation, okay, on both sides by z, then on the left hand side it will be delta z by z, okay, like this, plus minus. And if you divide it on this side also by z, z means on this right hand side you take it, z is equal to a divided by b, right? So this z will be cancelled, and you will have as what on the left hand side 1 plus minus. If you divide it z by z, then you will get 1 plus minus delta z by z, you will get delta z by z like this. And on the left hand side, if you cancel with this one, then what happened? You will have only 1 plus minus delta a by a whole into 1 plus minus delta b by b, like this, right? You try to open, okay, try to have the simplification on the right hand side so that it will be equal to what? 1 plus minus of delta a by a. If you multiply it with 1 with this and with this, okay, then you will get it like this. 1 into 1 is 1. 1 into plus minus delta a by a will be this one. Then next you try to multiply it with this delta b onto these both terms, okay, so that it will be what? Delta b plus minus delta b by b, and it will be what? Plus minus delta a by a into delta b by b. So as I told you that delta a and delta b are small quantity. If a smaller quantity is again divided by a bigger quantity, then this will be a very small quantity. This will be also again a very small quantity. So this term can be neglected as it is a product of very small quantities, okay. So now what remain is what? 1 plus minus delta a by a plus minus delta b by b. On the left hand side it will be 1 plus delta z by z, like this. So 1 and 1 can be cancelled. So your delta plus minus delta z by z will be equal to what? Delta a by a plus minus delta b by b. I missed one, that plus minus here. So what happened? You can write ultimately as what? Delta z by z as what? If you take it common for this plus minus, then it will be what? Delta a by a plus delta b by b, right? So what happened? Whenever a physical quantity is expressed as the division of two physical quantity, then the relative error in the measurement of that physical quantity z is equal to the sum of the relative error in the individual quantities. Got it? That was obtained in the case of product. So collectively we can say that when two quantities are multiplied or divided, then the relative error in the result is always the sum of the relative error in the individual multipliers, okay. Now this is all about that propagation that we have discussed, okay. And lastly, we need to find out, or we need to solve a question. The question is what? This is question number 1.29. A physical quantity P is related to 4 observable quantities, okay, A, B, C and D as follows. P is equal to A cube into B square divided by square root of C into D. The percentage error in the measurements in A and B, A, B, C and D are 1%, 3%, 4% and 2% respectively. What is the percentage error in the quantity P? Okay, you try to find it out only up to here. Don't try to find it out the remaining things, okay. So what happened in this measurement of A? The relative error is, the percentage error or the relative error is coming out to be what? 1%. 1% in A. In the measurement of B, the relative error is coming out to be 3%. In C, this is 4. In D, it is 2%. So we know that if it is in the form of a this one. I missed to tell you another one. Okay, suppose in that physical quantity, suppose if z, if it is expressed in the form of a power like this, okay, in the form of power, then what happened? The measurement in z, absolute error is denoted by delta z. In the measurement of A, the absolute error is denoted by E. So this is also same with that of the product of the same quantity with itself. Okay, instead of B, you may take it as A. Got it? So what happened? Your relative error will be what? Delta z by z. So the relative error in the measurement of z, as we have done in the case of product, it will be always the sum of what? The individual relative error of the individual physical quantity, right? So what happened? It will be what? Here also delta A by A plus delta B. Instead of delta B, we are having as A. So it will be equal to what? Delta A by A, right? So you take it this for A and you take it just as for that of B. Instead of B, we are having A 2 times. That is why I'm having as delta A by A, okay, instead of delta B by B. So what happened? Your relative error delta Z by Z will be equal to what? It is coming 2 times. So it will be equal to 2 times of delta A by A. Got it? So what happened? If a physical quantity is expressed as a power of another physical quantity, then relative error in that physical quantity will be equal to what? That power times the relative error of that physical quantity. Suppose if this is 3, then this will be coming another term here again, so that it will be equal to 3 times of this. So in general, we can express as z, if it is expressed as a to the power n, then relative error in z will be equal to what? This power times the relative error in that individual physical quantity. Got it? So what happened? As we are also having here what? The a cube b square, then what happened? It will be the percentage error in P will be equal to what? It will be equal to like this, 3 times of 1%. Got it? And as it is a product, it will be also, the relative error will be all what? Sum. Whether it is in the numerator or in the denominator, doesn't matter. It will be always the plus sign. Okay, so 3 times of 1% will be like this. Next, it will be 2 times of 3%. Why? Because the power is 2 in the case of B. Okay, it will be 2 into what is the relative error, percentage error? It was 3. So 2 into 3%. Then you need to keep on for that of C. The power for this C is half. So it will be a half times that of the relative or percentage error is 4, plus next is what? Half times, because for D the power is also half, so half times the relative error is 2. So in total you will get as 3% plus 6%. Got it? Next is what? If you cancel it, this half with this 2, it will be 2. So 2%. Next it will be 2 to cancel, so it will be 1%. So how much it is? So it will be what? 3 plus 6, 9, 10, 11, 12. So it will be equal to 12%. Okay. So the relative error in the measurement of P will be equal to 12%. Got it? So this will be the answer or the solution for this question. Got it? You try to solve it like this. Try to find such numerical problems in your textbook or in reference book, and you will able to solve it. Okay. So with this, we will come to the end of our today's class. Let's wind it up here. Thank you. Okay.